today we will see what is Radix Sort and how Radix Sort work, the time complexity and the best and the worst case for the Radix Sort. So first of all, the basics. We have seen many sorting algorithms, but this one is a little bit different. Okay, it is not based on the normal strategy that we follow between comparing the numbers, swapping between them, but it's a different method. And it's also interesting because it needs actually very small amount of space and small amount of data movement. Okay, and you don't have to do any comparisons between the numbers. That is the most interesting part. So if you in any operation, if the comparison is you want to avoid the comparison operation, Radix Sort is the way to go. So in computer science, Radix Sort is a non-comparative integer sorting algorithm that sort data with integer keys by grouping keys into by individual digits. You don't have to memorize this definition, just remember this key point. This is a non-comparative integer sorting algorithm. Okay, it sorts the data with integer keys, okay, by grouping keys by individual digits. Okay, now let's see what does this mean. If I go to the next slide. Okay, sorry, I actually skipped a lot, my bad. Okay, now first of all, why it is called Radix? Is it named after a person, like, you know, Floyd Marshall algorithm? It is named after scientist Floyd and Marshall. So the answer is no. This is called Radix Sort because Radix means the base of system numeration. For example, the decimal number system that we use every day has 10 digits. Okay, so the Radix is 10. So that's why it's called actually Radix Sort. Now there are two types of classification. One is LSD, least significant digit Radix Sort, and one other is MSD, most significant digit Radix Sort. So what we will see the example and you will understand what does the difference between these two. So the first thing that if you are applying the Radix Sort, okay, how many comparisons you need to do or how many passes or iteration you need? The answer is, if you have these numbers in the array, okay, the number of operations or the iterations you will need is 4, because out of all the digits you see here, this one is the largest one. In it have 4 digits. Okay, 1 2 3 4, and that's why you will need 4 passes or 4 iteration in the Radix Sort. Now let's see, without any further delay, let's see an example. So let's assume this is my input list and I will use Radix Sort in this algorithm. Okay, now first thing what we will do, we'll start with LSD, that means least significant bit. You know that in a number the last digit is the least significant, then this is second, then the third. Okay, and this is the most significant bit. Okay, now first what we will do, we'll compare all the first digits, okay, oh sorry, the last digits, the least significant bits, and we will group them depending on what digit we have. So here we have 6, we have 8, we have 6, we have 1, we have 6, 1, 8. So what we will do, okay, we will actually make a group, okay, up, and that will be, you see, the first we have marked all the last digits, the lower digits, and then okay, we will make a list like this, 0 to 9. Why 0 to 9? Because in a integer, the decimal system where the radix is 10, the possible digits are up to 0 to 9. There are no other digit possible. We all know that. Now back to it. So we will sort the, what we will do, we'll actually 126 will go to the this 6. Okay, this you can call it boxes, or you can say it a list. So 126 will go into this list, 328 will go into this list because the last digit is 8, 636 will go into this list, and so on. So you see, one by one, you see 328 will go to this list, 341 will go into this list, 416 will go into this list, 131 will go into this list, and gradually all the numbers are listed here. So what is the next step? So what we did, we actually by the value of the last digit or the lower digit, we have actually grouped the number into different categories. So this is the category for 1. All the numbers we have 1 as the last category. This is 6, this is 8. Now the next step, we will start from here. So after this, we'll again push them back into the array. and the array will start from first position. So 341, 131, 126, 636, and so on. So we just from this list we'll again put them back into the array. Now what is the second step? Now we will continue doing same thing, but now we will do it for the second digit, okay, or this past two. That means initially we compared for the last digit, and now we'll compare for the second last. And now if I again do so, okay, if I again make a list like this, so 341 now will go into this area, 131 will go where? Here, because the middle digit is 3, so it'll go into the group of 3. 126 will go here, 636 will go 636, right? So it will go here. So let's see, 131 goes here, 126 go here, 636 goes here, and you can assume 416, where it will go? It will go in the first place because the middle digit is 1. 328 will go here because middle digit is 2, and finally 328. So again what we will do after doing so, we'll again push them back into the array. So after pushing them back into the array, okay, so first we'll write 416, then 126, then 328, then again 328, then 636, 341, and so on. Okay, 341, 636. Okay, what does this came from? I think it was written by mistake. I don't see any 131 here. Wait, let me check. Oh, there's a 131 here. So it was actually by mistake they didn't write 131 here. Okay. So now this is our last step. What we will do again, we will group the number, but this time we will group the number using the first digit. So if you group the number using first digit, 4 will go into this place, 126 will go into the first place, 328 will go into the third place, 328 again go here, 131 will go into the again first place, 636 will go here, and finally 341 will go into the this place because 3 and 3. Now after this time you'll see the magic happens. Okay, what if we push them back into the array? Now if you look into this array is actually a sorted array, and this is why it is actually called a unique type of sorting algorithm, because what we didn't do any comparison. We just grouped the numbers into different areas, pushed them back into the array, and we just did it for 3 times. Okay, because there was 3 numbers in the digits, 3 digits in the number. Okay, and after doing 3 iteration, you will see that all the elements you have are actually sorted, and the completed array looks like this. So this is actually, that's why it's very interesting. And also we didn't have to do any comparisons. Okay, and it's actually generalization of another sorting algorithm that is called bucket sort. Okay, so bucket sort is a little bit more general, more how should I put it, more a little bit advanced, but this is actually Radix sort is actually very simple and generalized. Okay, so it actually you see the bucket, this is called bucket sort because you see the numbers that you are putting here in the boxes, we can compare them with a bucket, so we are putting them in different buckets. Okay, so finally Radix sort is stable, Radix sort is fast. Okay, it the algorithm is very simple. We first have to create an array of elements. Okay, we have to call the functions repeatedly, okay, depending on how many digits we have, and the function will return us the sorted array. And about the complexity, each pass has, you know, a over of number of digits that we have. So if we have, you know, like we are working with decimal numbers, what is the base of for decimal numbers? 10, right? So we'll have a 10 boxes or 10 buckets, and depending on how n numbers. Okay, so if we have like a number like let me write it down, it's easier for you to understand. So if you have a number like 413, that means we have to go 3 times. If we have a number like 2, we have to go 1 time. If we have a number like 1 2 3 4 5, okay, so if the highest number, we have to count the digit of how many digits you have, and we have to iterate that amount of time. Okay, so these are called passes. So the algorithm complexity depends on the number of passes. Okay, and finally if I just think that number of passes is nothing but actually a digit, right? So it basically a constant. So if I just simplify overall, okay, for you this, you can say that the overall complexity is order of n. Okay, because we know that n plus n is also n plus 2 is also n, right? So here, after all this, we can do this all these calculations, or we can say that in general that complexity is order of n. Okay, now is where is actually applied. Okay, this is actually applied, you know, in most cases in parallel computing. Okay, we use the Radix sort in case of parallel computing, and this is something that you will learn actually not now, but after in your, I think in your advanced courses. So this is all about Radix sort.